Good afternoon, everybody. I'm very honored to stand here today and represent the cooperation between Vietnam and Hungary. Actually, I originated from University, and now I'm FAO student studying veterinary in San Juan University and works as a trainee in Katki. Today, I would like to introduce you about my work cooperated with the colleges in Katki. So, is the title of my presentation today. So, today's topic is related to the assisted production technologies and gene conservation. As you know, gene conservation is becoming a very significant issue all over the world because of industrialization. So, that's why we really focus on the gene conservation with very highly assisted reproduction technology, and we compare the slow programmable and pellet method of the guinea fowl spermatozoa cryopreservation. I think everybody knows about the guinea fowl because you have heard a lot about the guinea fowl from presenter of University. So there's a question, why the guinea fowl is our choice? Because if you read the FAO data, you will see the guinea fowl is listed in the endangered list of endangered species list. Another reason, until now there's only single study that has been available on the sperm freezing of the guinea fowl. So I would like to introduce a little bit about the cryopreservation, just give you an idea what is it. Okay, the cryopreservation of the semen is a process, in vitro process, that cool down the temperature of the semen and stop on the metabolic process. So you can store the semen for a long time. So why is the cell gene conservation? You know, we have in vivo gene conservation also, but there's a lot of risk from the environment. You know, the global warming, about the keeping system also. But for the in vitro gene bank, you can avoid all the risk from the environment. I think it's the most important thing. And why the semen cryopreservation is the most practical method? Because first, it's cheap. It just needs liquid nitrogen if you do the vitrification method. Another thing, it's very easy to carry. And I think it's very, really easy for the Vietnamese practitioners to do the cryopreservation also with this method for long-term storage. So here's the picture I want to demonstrate about the cryopreservation. A little bit more information on the cryopreservation. The cryo is the suffix. It originated from the Greek language. It's krios, so it means frost. Means we freeze the sperm. Okay. Okay, I'm talking about the material and method. It's really simple, so I just want to point out some important thing. About the animal, we use very small number of animals. It's 30 and 1 year on rural Hungarian guinea fowl. You know, the Hungarian guinea fowl is not in the endangered species list of FAO, but if you read it, there's some variety from Africa. It's extinct already. Okay, so the keeping method, the most important is the individual cages. Why? Because the guinea fowl is really aggressive. So we need to keep them in the individual cage just to restrain them first. And then it's easier for you to catch them to collect the semen. It's really practical. Okay, so the semen collection, the photo demonstrates you how we collect the semen from the guinea fowl. We collect it twice a week and for 2 months. You imagine it's really, really hard work for us because we need 2 practitioners for each occasion. And we use the dorsal terminal masses technique. It's really similar to the goat semen collection, but for the guinea fowl, we need some experience with the guinea fowl because they give very less amount of semen. So you need to be quick, you need to store the semen, and you need to keep it safe for transportation. So how to evaluate the protocol? There's two different assays. You can use the in vitro sperm qualification. It's faster and its motility you can check with the microscope, or sperm concentration or morphological abnormalities, light and dead cell ratio. We use the staining method. It's visible under the microscope also. You will see the color of the sperm will change if it's broken or any piece of the sperm is broken. And I think you know that the sperm of the chicken is elongated and very different from the mammals. So if there's any pores on the membrane of the spermatozoa, the staining, the dye can get into the sperm, and it's visible. It's pink color. You can see it in my poster. And about the in vivo sperm assay, it takes a little bit more time, and we based on the principle artificial insemination. We use this reproduction technique to help us to evaluate. So we use 3 different groups, one for control, one we inseminated with the fresh undiluted frozen Taurus semen, but we use different protocol for this product. The slow method and the very fast method, so-called vitrification. The keeping condition, you have to make sure it's the same. And we inseminated 3 times a week for 3 weeks long. You know, because the amount of the guinea fowl semen is really, really small. So you need to make sure the inseminated dose is big enough. Okay? So with the artificial insemination, we can check the fertility, and we characterize it in 3 categories: the normal development, or the early embryo death, or is unfertile egg. Here is the protocol we use in the experiments. The first one is the slow programmable with the machine equipment. It is cost a lot, believe me. And the other one is pellet formation. It's easier for you and it's very effective. So the main difference between this protocol, you see at the breathing rate, the equipment will set up the breathing rate at 2 different periods, until minus 30 degrees and until minus 60 degrees with different rates. Okay, and we use different cryoprotectants. See, these mean cryoprotectants. 10% ethylene glycol. In the other protocol, pellet formation, or it's called vitrification. It's very fast, sperm freezing. So we use the diluent. We use another dilution rate, and we use another cryoprotectants. It's DMAs. It means dimethyl acetate. Sorry. I will tell you later. I'm just nervous. So the difference is you drop it directly in the liquid nitrogen. It won't take so much time. It can finish in 15 minutes. Okay, here's the result. It's very simple graph, but the most important thing is the yellow one. You see the abnormality. It shows you abnormalities in the slow programmable protocol. It's really big gap. So it shows that there's about 20% of abnormal sperm cell after freezing and thawing. But in the other case, vitrification is much smaller. It shows you the quality of the frozen and thawed semen. Second one is the survival rate of the live intact spermatozoid. It's very significant difference in the vitrification. You see, but both of them is accepted. The third one, I would like to show you the fertility and embryonic mortality of this experiment. So, what is the more important? The tendency. You see the tendency of the second column and the third column. You see, the fertility is not very high, but the important thing is the red one. the embryonic death of the embryonic death. You see in the vivification, there's a big gap, the big red column in the first week, but in the third week it's really small. You see the significant difference. That's why it makes vivification is an effective method. But in the slow programmable, it's quite the same in 3 weeks. So it's really short experiment, but it takes a lot of time. So I would like to conclude some point. As I say, pellet method result in a higher fertility rate, as you see from the graph. And the second one, the slow protocol, produce an accepted sperm survival rate, but very, very slow and it takes long time. The third one is in vitro and in vivo tests are inevitable for testing of effectiveness of freezing protocol. I would like to talk about that. You see, we use different methods to evaluate this protocol, but it's simple and it's not accurate. So it's not very 100% accurate. Nowadays, there's a lot of study about evaluation of sperm freezing protocol, and flow cytometry is one of them. So, but it costs a lot. A short message to you, because my topic is working concerning the biodiversity and gene conservation. So I would like to tell you the variety is the spice of life. If you can maintain the biodiversity, you can keep the balance of the genetic resource. You can improve the sustainable development of agriculture. Okay. Finally, I would like to say special thanks to Kaki, Hungary, and Concord University, who give me a chance to stand here today. And really, really thank you, Lassie, for the introduction.
Thank you. Ladies and gentlemen, any questions? I have just a very brief comment regarding the flow cytometry. The flow cytometry in itself is not very expensive. The instrument is more expensive than the average instrument when you buy it first time. So I would like to suggest that flow cytometry is really not introduced into the veterinary sciences, but it would certainly pay out very soon, and there is a tendency in the world that it pays out. But let me then take the opportunity and ask you another question. So, and let's return to the mycotoxins. Mycotoxins are known to influence the reproductive system very seriously, among others. And I don't know whether the production, the spermiogenesis is influenced by the mycotoxins. So do you have any such results or related results or knowledge about it? How is it in poultry?
Thank you very much for your question. As I know, the flow cytometry is much more expensive than liquid nitrogen. That's what I mean. Okay, for the second question, I didn't have any experiment with the guinea fowl affected by the diet, with the mycotoxin. But I have read some experienced people who work with the geese. So the mycotoxin in the feed may affect the reproduction irreversibly. You know why? It can reduce the fertility, but it repeats again and again, year by year. But it's not stopped like it affects only one seasonal period. No, it affects for a long time, so you cannot use it anymore. And I do believe it's very good field to start the research with mycotoxin, because I do believe it affects very much the reproduction of guinea fowl. Thank you.
This word very interesting research. So I have some question for you. So you store this spermatozoa for your research. So how can maintain or store it for a long time? Yeah, for your research or for research in genetic country. And the second, when we use the fast or low protocols in this research, however, we can see that in figure 3, the unfertility rate was lower than the control. So, yeah. So how can you explain and how can you improve the unfertilized egg?
Thank you very much for your question. So the first question about the vitrification, how can we store it for a long time? You know, when you cool the spermatozoa down to about minus 96 Celsius degree, all the metabolic process will stop. The metabolic process, it causes the death of the cell. So that's why, it's the reason why we can keep it, we can store it for a long time. Okay, is for the first question. And the second question about this figure, right? It's about the figure. So you see, when we freeze the sperm and we thaw the sperm again, we cause a lot of broken, sperm. We affect the sperm, and the survival rate of the sperm is much lower. It's much lower in normal case. That's why the fertility is much lower. I think it's logical.
And did you know the way to improve?
So for those questions,
Yes.
you said this, you can store for a long time the spermatozoa. However, when you store for 1 year, 2 years, 3 years, it's still the death rate will increase. That means you have to another method to store them again or to improve the survivals of the cell. For the second question, so you explain it's okay, but this another that you have the way to improve the fertilized egg in your experiment.
Fertility.
Yeah.
Okay, thank you for your comment for the first question. So far, I have worked at the Getty only for 2 years. I don't know exactly what happened after 2 years of the samples. Is for the first question. And to improve the fertility of the semen, yes, we work to improve the semen, but we evaluate 2 protocols because we want to improve it. That's the reason for our research. So it's the final objects. Final destination. Does it satisfy you? Not yet. We can discuss more later. Thank you very much for your patience and attention. I wish you have a good time here in Qatar. Thank you.
Thank you.
So the next speaker